My name is Nikola Gruchevsky. I'm a software engineer at Grafana Labs, working on this product, Grafana Beyla, that was announced here. This presentation is about Grafana Beyla, and here I'm here with my colleague, Gautam.
Hey everyone, again, I'm Gautam. I'm a product manager at Grafana Labs, but only until the end of the week, so you'll see why.
So we're going to try to make this talk interesting, even though it's a little bit about a really deep technical topic. So hopefully we'll succeed. It's an exercise in doing that. So, all right, you probably know the drill. We have a QA section at the end. You can use this QR code to get the Slido link. All right, so what is Grafana Beyla? For those that don't know, it's an auto-instrumentation tool that can do instrumentation for both application and network metrics. And I'll talk about what they mean and what they do for you and so on. But it's built, importantly, with this technology, eBPF. And I was told I could say this, but I'm going to tone it down a bit. The acronym eBPF means something, but everybody talks just out of eBPF. And I like to say about the F stands for F yeah. So, and we support instrumenting in all services. So it doesn't matter what programming language. We're going to set some lofty goals here. All programming languages, variety of protocols. It's Kubernetes aware, so it can pick up all your labels and stuff you have and export them in your metrics and traces. Sounds very promising, right? Okay. All right, so what does that mean, really? So on here on one side, I have a K9 screenshot of something that's a cluster with a bunch of services running there, and boom, you can easily get red metrics out of it. And build pretty graphs and even see upstream and downstream services, how they connect and talk to each other. It's kind of cool, but with Beyla 2.0, we can also get distributed tracing for HTTP. No gRPC for now, but HTTP distributed tracing out of the box. One tool, one installation of this thing does the whole thing. And this distributed tracing is kind of interesting because here I have an Istio wrap service. So we're not getting only the traces for the application, we're also getting the traces for Istio itself. So you can see how much that adds delay sometimes. And we can also get network metrics. And why is this important? Because we can correlate now these network metrics with the previous, say the red metrics. And we can see if maybe our slow responses are related to some extra bytes, loads, and so on, or maybe correlate them to the CPU utilization and all this stuff. And because we pick up all those nifty labels out of Kubernetes, we can pick up stuff like the AZ zone in which the service is set up. So if you have a misconfigured service that's talking to a remote database and that's costing you on your cloud bill for the AZ zone traffic, you can detect it with this and find out those misconfigured services. So, how does this all work? What have we done here? What is this eBPF? Yeah. So, well, it's a technology built into the Linux kernel. It's a virtual machine for which you can actually build programs. And you build these programs, and what they do is they attach to various aspects of your application stack. So application is running and written in some programming language. Maybe it's using managed runtime. Maybe it's just a binary. It's using any libraries on your system, and eventually it's using the Linux kernel. Well, with this technology, we can tap into any aspect of this application stack, and we can extract signals, which we then turn into telemetry. We send them to an OpenTelemetry format, or we can export them directly to Prometheus. This is how this magic happens. Now, why is this better than everything else, in my opinion? Because one thing, this technology will never destabilize your kernel. It's not like the kernel modules of the past where you load a kernel and boom, your machine is dead. This is built for the purpose that you can plug something in while your production systems are running, you can take it out, and there should be no impact on your system. And that technology is actually real because of this verifier that sits there. It won't let me load a program that could potentially destabilize the kernel. The programming language we use here is C-like, but it's not even Turing complete. You cannot actually write a program with loops, for example. So with that said, let's look what this does in practice. So here I'm going to try to build a very simple service I don't know, maybe takes this one API through HTTP and it talks to Redis database, right? We've all built something like this. And so what do I build this in? I have lots of choices. I can build it in Python, I can build it in Java, maybe Node.js, whatever is my favorite programming language. And then once I build it in that programming language, I have lots of choices about frameworks that I can use to build this with, right? So I can choose the stuff that fits my way of programming. Or maybe I don't know what I'm doing, I'm using an LLM, and it suggests something, I'm just gonna go with it, right? But either way, for this purpose, let's look at something if we did this in Python. All right, so on one side, you can see all the possible frameworks I could have chosen to build my service, right? Whatever, I found something on the internet, looked good, I tried it. And on the other side, I have many choices that I can actually build the Redis communication with. So how do I actually get from this telemetry? I'm a software engineer, I start building this service, I build it out, and it's working. And then maybe a couple of months later, I realize, oh, I should be monitoring how this performs in production. Well, how do I actually add telemetry? One obvious way is maybe I'll manually start using the OpenTelemetry SDKs and add my trace points and spans and do the context propagation myself, but it gets tiring really quickly. It's difficult to maintain, it adds so much code now that it's not actually related to the logic of the application service itself. I would not want to do that. So then if I was really lucky, maybe the libraries that we're using support auto-instrumentation, or the versions that I picked up. Maybe it's a service I wrote 3 years ago, and it's using some obscure library that's not actually supported by the OpenTelemetry SDK instrumentation. So these problems arise, more than you know, with various people trying to implement this, and we've seen a lot of these cases with Grafana as well. But it's not all doom and gloom, right? If we will actually look at this and zoom out a little bit, but really, there's only 2 protocols here, right? I mean, there's HTTP and Redis. Could we not just instrument the protocols and get the data there and figure out this? Why worry about what the frameworks are doing? They're all speaking the same language in the end of the day. And this is a sort of insight we had when we began working on Beyla. Because Beyla is essentially a protocol instrumentation tool. It understands HTTP. It doesn't know that this is running Python, running on top of this framework, Django. It doesn't care. So let's see how Beyla actually does this instrumentation. So what we have here is we monitor the TCP stack, so TCP send message, receive message. Therefore, we're able to see the HTTP protocol incoming. Even if it's using SSL, Beyla taps into libSSL and is able to extract the information again. Then we monitor what's happening in the actual application itself, how it's managing threads, how those interact with the Linux kernel to pass the work around. And on the other side, we'll look at what the protocol Redis is doing and extract information about the Redis protocol. Matching this together through various logic, we're able to do the exact same thing as you would do with your manual instrumentation. Again, we didn't care pretty much what the programming language is, which is sort of true, not always. We do special things for, say, Go to handle Go routines, and Node.js to handle the async event loop, which is different than running normal threads. With that said, here's a simple trace what this would actually look like if you were going to instrument this application with Beyla. Nothing to it, right? So we have the GET request coming in, and then we see that it's stacked under something like a Redis call. Now, this is a pretty simple case. Traces can get a lot more complicated, but this is the gist of it. Now, it may seem like, okay, that sounds good. Let's go and do it. This was not easy to actually do. It took about 2 years to get this right, more or less. We've been working this, I personally, since I started at Grafana, on this one project, doing just this. It's been a lot of effort. And having said that, we thought about, all right, so this does a lot of things, but it's not about just Grafana. We're not going to build this so we can run it with Grafana products and we're going to be bundling this with Grafana. We build it for the community. We build it for everybody to try this. And initially, when I started on this journey of building this eBPF tool, I didn't know what to expect. What was this about? Was this ever going to be as good as instrumenting with the OpenTelemetry SDK? But as we built it and we actually had people use it, we realized there was actually a specific gap in the OpenTelemetry tooling that this tool was covering. And that was places where people could not instrument the applications, or they wouldn't. Let's say they just didn't have enough time, or people that used legacy software, which was not easily instrumented with the OpenTelemetry SDKs, or perhaps they didn't even have the source code of these applications they wanted to monitor. They were just binaries they were using, right? And this is the case where Beyla really fit and closed the picture. With that said, this made us kind of move to the next step in the evolution of this product, which is we have actually donated Beyla to OpenTelemetry. There was a process that started about 6 months ago that we worked with the OpenTelemetry community and CNCF to actually make this project go beyond just Grafana. It's a community-owned project, but it's not only that. Grafana will stand behind this new project. So all the maintainers of Beyla will work full-time on the upstream project, upstream first, where Beyla will eventually be just Grafana's distribution of this OpenTelemetry eBPF instrumentation tool. And now, thank you. Now I'm going to let my friend Gautam here talk about the stuff he's been doing with this tool, which is a lot more interesting than my spiel.
No, thanks a lot for all the work and for creating Beyla. Now you've seen how Beyla works. I'm going to talk about a little bit about how I am using Beyla and what the experience of using Beyla is like. So for a little context, I've been an engineer for 5 years in Grafana. I was building all of these products in Grafana Cloud. I was on call for these products. And I was using everything that I was building, and I had a fair idea of what was good, what was bad, what was missing. And I had this crazy idea that, oh, I can be a good product manager because I know the product and I know what's missing. And then I became a PM, and I stopped using all my tools, which honestly kind of sucked. So after 5 years, I kind of decided to go back to engineering because I realized I like building tools, but I also like being on call. And I actually sorely miss being on call. So I also did not want to wait to go back to engineering to kind of use all the tools that we were building at Grafana. So I decided to kind of collect all the Raspberry Pis and random stuff and build a Homelab. Turns out, I have a lot of different random stuff just lying around. And I was like, oh, I might have a problem here. But now we have a solution for the problem. So yeah, I collected all the Raspberry Pis and all the different weird NUCs and old things, and I just hooked them up. I ran Kubernetes on it. And I was like, OK, now I want to kind of use all the tools that we were building. But before I did that, I needed to monitor some services. So I decided to start self-hosting and running a few services. So self-hosting is basically the process of running your own service, self-host the service on your own infrastructure instead of relying on a cloud vendor and paying them money or your data. And basically, I had no clue. I just built up this whole Homelab. And there's this amazing website called Awesome Self-Hosted that gives you all the potential things that you could self-host. And I've scrolled this multiple times. And I started self-hosting a few things, like my habit tracker or this bookmarking service, where every interesting article I find, I archive it. Even if the original link disappears, I still have a copy of it. I can search through things and stuff like that. And I started slowly adding more and more things to this Homelab. For example, I quit Twitter even before Elon Musk bought it. And I really missed tweeting out. So I wanted to kind of have a Twitter, but for myself. So there's this amazing project called Memos, which is like Twitter, but for yourself. So I just started using that. And I had this, one of the ideas that I had was, what if there's a magazine for random stuff my friends write? And yeah, a month later, I have a magazine for me and my friends. So yeah. But now that I was running all of these weird services, I now was like, OK, I'm ready to observe them. So how many of you have a home lab? How many of you get paged if one of the services in your home lab goes down? OK, you brave souls. Me too. Me too. Yeah. And of course, there's the traditional infrastructure monitoring with Node Exporter and Prometheus. But I wanted to kind of go beyond that because I was the PM for APM, the APM PM. So I wanted something like this. I wanted like red dashboards and traces and all the cool stuff that we were working on. I also wanted SLOs for whatever reason, but turns out they don't work. When you don't have traffic, you have 100% of your requests succeed, so you never get paged until you use it. But anyways, now that I was self-hosting all of these applications, I wanted to monitor them. And turns out, for traditional hobbyist use cases, most of the applications have no metrics at all. Even if they do have metrics, there is no consistency between applications. So essentially, if I were to kind of use the metrics that the application emit, I need to have like a set of alerts and dashboards for each different application, and this is just too hard to manage. And finally, I had this weird idea that I might be able to contribute back if the applications were in Go, so I decided to run Go. But then there is no auto-instrumenting for Go. If it was Java, I could do the Java agent, and maybe I would have like consistent sets, but well, I dug this hole myself. So I came up with a criteria on how to monitor these. First, it needs to be easy to instrument. No matter what I pick from various, like I run self-hosted applications of various languages and frameworks, they need to be easy to instrument. I need to have one set of alerts and dashboards for everything, and I can use a drop-down to kind of pick application A and application B. I run K3s, so anything that I pick needs to work with Kubernetes. But I had the most important criteria. I like public speaking, and I was like, I need to build all of this with cool tools that I can blog and talk about and get accepted at conferences. So yeah, with this criteria, there's actually only one answer for the consistent set of metrics and dashboards, which is OpenTelemetry semantic conventions. So Otel semantic conventions, I think, are its superpower. We just say, hey, if you're monitoring HTTP, you need to basically have this particular metric emitted with these particular attributes, and there's the same across frameworks and languages. So if I rely on semantic conventions, then I can have one set of dashboards and alerts. So how do I get semantic conventions out? So there's something called the OpenTelemetry operator, which helps you auto-instrument all your applications in Kubernetes. So it provides in-depth instrumentation, like almost native instrumentation where possible. However, it's not always possible. For example, with Java, it's possible, but with Go or like Rust, it's not very possible because there's no auto-instrumentation. However, if it is possible, you can kind of use auto-instrumentation, but also extend it with additional attributes inside the application code itself. So you don't need to fully instrument it. You can partially instrument it and add context. However, you also need to tell it, hey, this is a Java service, and you need to restart that service for all of this to work. On the other hand, we have Nicola and Beyla, who basically, yeah, like it's just a daemon set that you run. It's a simple Helm chart. And it gives you everything out of the box for all the languages. However, the drawback is that you can't extend the telemetry. So whatever Beyla gives you is the kind of final telemetry. You can't add additional context in the code itself. Cool. Well, I chose Beyla because it has eBPF, and eBPF will get me to conferences. All right. So how do I deploy Beyla? It's actually quite simple. Unless you're running a Raspberry Pi. If you're running a Raspberry Pi, you have to recompile the kernel. But yeah, if you're not running a Raspberry Pi, you just, you just need to run this Helm install, and it's super easy to get started. And once it started emitting native semantic conventions, I could use this dashboard created by my colleague to kind of instrument everything. So let's quickly go through that. Can we switch to the live demo? Right. Oh, yeah, wait. No.
Switch to live demo. Yeah.
I am mirroring, I think. Yeah, I'm mirroring. Can we switch to the live demo? All right, OK. You don't need it. It's a very cool dashboard. Oh, yeah, it works now. OK. So, so yeah, OK. So yeah, you can see kind of the red metrics. You can kind of see the inbound operations, like the different kind of operations that was happening on this particular archival service called Redec. It's like you can choose a different service. It just instruments everything in my Kubernetes cluster. What is really, it also shows you outbound requests and stuff like that. But what is really cool is the traces, which you can kind of see here. Again, I don't have traffic. I just have a black box exporter probing it. But you get full distributed tracing from the black box exporter to Redec, which then redirects it to the login thing. So there's like a 302, and then that goes back to Redec. And this is like, neither black box exporter nor Redec is instrumented with Otel. All of this is coming from Beyla, which I think is really cool. If I had a super cool, huge architecture, I think the trace would look cool, but I don't. So yeah, OK, let's switch back to the slides. OK.
It's happening. It's happening.
OK, whatever. How many of you have the habit of buying books but not reading them? Ooh la la, OK.
Hey,
Turns out I have the same skill. There's a name for this skill. It's called Sundoku in Japanese. And well, I have a lot of books, and I don't always read them. And sometimes, like 3 times, maybe 4, I bought the same book twice. And I was like, OK, this needs to be solved. So I built an application to track all my books and exactly which shelf they are on. And then to do this, I bought a supermarket ISBN scanner. So yeah, so I have this application where I scan a book, scan a shelf, and it belongs to that shelf. And I can buy a new book. I can just scan it, and it looks up the ISBN details and populates the information. So this is a very simple service that I've written. I'm running it on my Homelab with Tailscale and all the cool things. I even built a TUI for it, because I can't build UIs. So I wanted to have borrowing and stuff. So I decided to instrument this natively to understand the difference between Beyla's instrumentation and native instrumentation, like what is different. So yeah, so basically, essentially, there's this like 200 lines of boilerplate that I copy-pasted, maybe asked ChatGPT to do it. And then it basically set up tracing for this Golang application. All I had to do was like set up Otel SDK and then put all the garbage here, and then it works. Easy. With Beyla, there's a debug endpoint. What it does is it gets like this ISBN lookup. It sends a request to Google Books. It sends a request to Open Library, and then merges the data to kind of look up the book details. So this is what Beyla generates. You can see like server.address, HTTPS, all of this, really cool. I did this with native instrumentation, and basically all I got was, oh, there's a request on this endpoint, but none of the outgoing requests. Turns out there's this thing called context propagation, which ChatGPT did not do for me, so I had to do it manually. So once I've done that, and once I've changed HTTP to Otel HTTP, I could see like the outbound calls, which was really cool. But then, instead of server.address, I was looking at http.url. And it's like, wait, with semantic conventions, everything needs to be the same. Technically, yes, if you're on the same version of the semantic conventions. Turns out the SDK is on a way older version of the semantic conventions, so the SDK generated telemetry and Beyla generated telemetry is different. Beyla is on the latest version. I don't know if that's a good thing or a bad thing, but I found that the
it's a good thing.
Yeah.
On the stable one.
Yeah, cool. And the next thing was I wanted to instrument SQL calls. So I do a lot of SQL calls into the thing. Like I look up all the books and the shelves and everything. And I wanted to do SQL instrumentation. I Googled for it. Turns out there's 7 libraries that do the same thing, but in slightly weird ways. So I asked ChatGPT to pick one of these SQL instrumentation libraries for me, and the ChatGPT picked the 3rd one. I don't know why, but it's OK. and I instrumented the SQL calls. It was quite simple. I just needed to say Otel SQL instead of SQL and register DB stats. And each SQL call was its own trace. So again, ChatGPT did not pass the context. And so I had to kind of go back and manually change every call to pass the context here. And once I've done that, you can kind of see that all the SQL calls are nicely instrumented. So, oh, by the way, there's like 2,000 SQL calls every time I do a lookup on books, because ChatGPT wrote this and not me. But I only have 250 books. So it's not a performance concern yet. So it's OK. What I found really interesting is you get full details about the SQL query and the templated queries that are being done if you manually instrument it. While Beyla looks at like the kernel level, and it can look at the whole SQL query, but it does not want to show it to you because it might have secrets in it. So this is kind of what you get between native instrumentation and auto-instrumentation. It's a slight trade-off. But what I realized was it's actually not Beyla versus native instrumentation, but rather it took me like several hours to manually instrument a very simple Go application. And if you suddenly have like 20 applications, you tell your engineers, now you have to go manually instrument everything, they're just going to go on holiday together. So what Beyla gives you is within one command, you get 80% of the way. And then you can use your engineering bandwidth to say, actually, these two applications are the most important. Let's manually instrument them correctly. And then you can kind of go through this. So you can think of Beyla as a fast start before you go to the whole full instrumentation. All right. That's everything that I have.